Today's topic is structure of atom. Let's review the old versions. The first atom structure of atom given by the J.J. Thomson, as he said that he is the first scientist who has given the concept of the structure of atom. He gave that it is like a plum bloody fruit where all the seeds are going to be embedded in it in a red color resid, say it as a watermelon, and entire the red color resid is known to be a positive charge and the seeds are going to be a negative charge which are embedded in the red color resid. Even though scientifically it is proved wrong, but he is the one who has given an idea to think about the structure of atom. So whereas the later Rutherford has come, and as we universal fact is positive and negative, there is a direct interaction between them spoils the atom, but atom is not going to be spoiled. And also he said that by his gold foil experiment, such that entire the atom is going to be empty space. But J.J. Thomson said that entire the atom is filled with the positive charge. But he proved with the gold foil experiment by using the alpha rays. Rutherford confirmed atom is almost empty space. Only nucleus is filled with positive charge. Thereafter, we have the nucleons like protons and as well as the neutrons. So we have the three subparticles: electron, proton, neutron. But according to the mass, we will only consider the protons and neutrons. According to the charge, we are going to be neutral as number of protons is equal to number of electrons. Let's think about it. For example, this is your atom and entire space is going to be empty. The nucleus is filled with the protons and as well as the neutrons. The condition is charge wise atom is going to be stable, atom is going to be neutral because number of, for example, say an atomic number 17 chlorine. So that 17 indicates number of protons 17, number of electrons going to be 17. So number of positive charge is equal to number of negative charge. So that charge wise atom is going to be neutral. And let's see about that. When it is having the 17, say it as a Cl minus, what it will be 17 only. But number of protons will be 17, electrons are going to be 18. So charges are changed. So 17 protons, 18 electrons. So whose charge is more? Negative charge is more. So that's why it becomes as a Cl minus. Whereas if you take as a magnesium and a magnesium plus 2, magnesium number what Nana? 12. So protons are 12, electrons are 12. But come back to here, protons are 10, electrons are 12. Protons are 10, electrons are 12. లేకపోతే protons are 12, electrons are 10. ఎప్పుడు కానీ గుర్తుపెట్టుకోండి, ప్రోటాన్స్ ఎప్పుడు చేంజ్ అవ్వవు. ఆల్వేస్ ప్రోటాన్స్ రిమైన్స్ సేమ్. సో ప్రోటాన్స్ ఆర్ గోయింగ్ టు బి 12, ఎలక్ట్రాన్స్ ఆర్ గోయింగ్ టు బి 10. సో ఇక్కడ ఏమైంది, నంబర్ ఆఫ్ నెగటివ్ చార్జెస్ ఆర్ లెస్ దాన్ ద నంబర్ ఆఫ్ పాజిటివ్ చార్జ్. సో దట్ ఇట్ ఈస్ గోయింగ్ టు బి Mg+2. సో protons are responsible for the sake of balancing the charge of an atom and to balance the mass of the atom. You don't consider the electrons in case of measuring the mass. We only consider the electrons in case of measuring the charge of an atom. అంటే charge ని కౌంట్ చేయడంలో ఎలక్ట్రాన్స్ యూజ్ చేస్తాం కానీ మాస్ ని కౌంట్ చేయడం కాదు. Because as we already know that electrons are revolving around the nucleus. ఇదేమో చెప్తున్నారు Rutherford. It's like a solar system. Like a sun is at the center, all the planets are revolving around the sun. In the same way, center is going to be nucleus. Around the nucleus, all the electrons are going to be revolving continuously. So, if you wanted to consider the electrons to be involved in the mass, electrons are going to be fixed at a point. But it is not possible. Always electrons are revolving around the nucleus. If you wanted to find out the weight of an object, if it is in running, you cannot find it out. అంతేనా కాదు, మనం పరిగెత్తున్నాం, మన వెయిట్ ఫైండ్ అవుట్ చేయాలి, అట్లీస్ట్ ఫర్ ఇన్స్టాన్స్ we should stop. Then we can find the weight, but electrons are not happening so. Always continuously electrons are revolving. అందుకని ఏం చేస్తాం, according to the mass wise we don't involve the electrons, but according to the charge wise we will involve the electrons to be measured. Then, and also what is an atomic number, what is a mass number? atomic number represented by Z, mass number represented by A. So atomic number is equals to number of protons. ఎందుకు నంబర్ ఆఫ్ ప్రోటాన్స్ అంటే మనకి ఏం తెలుసు, నంబర్ ఆఫ్ ప్రోటాన్స్ ఇస్ ఈక్వల్ టు నంబర్ ఆఫ్ ఎలక్ట్రాన్స్, దట్ ఈస్ ఫిక్స్డ్. But if any instance, if any chance, there is a chance of losing an electron, but there is no chance of losing of protons. కాబట్టి ఏంటి, protons are going to be fixed. Protons are going to be fixed, but electrons may be changed, may not be changed. ఎందుకని Mg తీసుకోండి. In case of Mg, 12 electrons are there. In case of Mg plus 2, 10 electrons are there. So there is a chance of lose of electron, so chance of gain of electron for purpose of stability. కాబట్టి ఇక్కడ ఏం చేస్తాం, అటామిక్ నంబర్ ఇస్ ఈక్వల్ టు నంబర్ ఆఫ్ ప్రోటాన్స్ అవైలబుల్ ఇన్ ఏ ఆటమ్ ఇస్ నోన్ యాజ్ ఏ నంబర్ ఆఫ్ ప్రోటాన్స్, ఎలక్ట్రానిక్ నంబర్ అని చెప్తాం. మాస్ నెంబర్ వచ్చేప్పటికి ఏం చెప్తాము, ప్రోటాన్స్ ప్లస్ న్యూట్రాన్స్, నంబర్ ఆఫ్ ప్రోటాన్స్ ప్లస్ నంబర్ ఆఫ్ న్యూట్రాన్స్. సో P plus N, P for proton, N for neutron. So number of protons and number of neutrons gives as a mass number. Here we are not using any of the cases as a electron because of electrons are not stable. They may lose, they may gain. So these are the old version of few things. And now come back to the structure of atom. We need to know about the spectrum first. Combination of the different wavelengths of light is known as a spectrum. Combination of different wavelengths of light is known as a spectrum. There are the two spectrums will be there: visible spectrum, invisible spectrum. Visible spectrum that can be seen, invisible spectrum that cannot be seen, where the UV rays are available in the invisible spectrum, whereas VIBGYOR is the best example for the visible spectrum. So let's find it out here about Bohr's model. First of all, Bohr is the scientist who has taken place after the Rutherford. First one name was J.J. Thomson. He has scientifically proved wrong, but though he is initiated first of the to know about the structure of atom. The Rutherford has come. He has given the two conditions, like all the entire atom is going to be empty space. He proved by using the Goldfein experiment, and also he has given a confirmation that it's like a solar system. All the electrons are revolving around the nucleus. Thereafter, Bohr has come. He supported the Rutherford model because he is the correct that all the electrons are revolving around the nucleus. But the condition is Rutherford did not explain as electrons are continuously. So ఇక్కడ మనకి ఏమవుతుంది, as he said that మనకి Rutherford did not explain as electrons are revolving around the nucleus continuously, so they need to lose energy, atom has to be collapsed. But whereas in case of the Bohr, electrons are revolving around the nucleus in a fixed path, so that there is no chance of losing the energy, there is no chance of gaining the energy. So these are called as the stationary orbitals, can be named as K, L, M, N. So these are called as stationary orbitals. Right. So they named as KL. What do you mean with the stationary orbitals? As long as electrons are revolving around the nucleus in these kind of the orbitals, they do not lose the energy. Those kind of electrons or energy is going to be fixed. So orbitals name cheptamu stationary orbital. Orbital is nothing but a path in which electrons are revolving. Right. So in case of the K, L, M, these are the main shells are available. Explained about by the Bohr's model. Bohr has been explained about the stationary shells, and also he explained that as electrons are jumping from lower energy to higher energy orbitals, when electrons are jumping from lower energy orbital to higher energy orbital, they need some energy to be observed. They need some energy to observe to reach the high energy orbital. So that energy is equals to h nu, and that should be equal to difference of the orbital. Difference of orbitals. Let's take an example. E1, E2. There are the two orbitals are there. E1 is the lower energy orbital. E2 is the higher energy orbital. ఇప్పుడు ఏమవుతుంది, electron is jumping E1 to E2. ఎలక్ట్రానిక్ జంపింగ్ E1 to E2 అంటే లోవర్ ఎనర్జీ నుండి హైయర్ ఎనర్జీకి. అప్పుడు ఏమవ్వాలి, ఎనర్జీ షుడ్ బి అబ్జర్వ్డ్, దట్ ఎనర్జీ షుడ్ బి ఈక్వల్ E2 minus E1. That energy should be equal to E2 minus E1, that always equals to h nu. H for Planck constant, nu for frequency. And this is absorption. Okay, but when electron is jumping from E2 to E1 అంటే higher energy orbital to lower energy orbital, అప్పుడు ఏమవుతుంది, energy has to be radiated, energy has to be released, that also should be equal E1 minus E2, that is also h nu. ఎందుకంటే whatever it may be, whether it is jumping from lower to high or whether it is jumping higher to lower, the difference of energy level should be observed or released, that always equal to h nu. This is given by the Bohr's model. And Bohr has been explained about the line spectrum. What do you mean by the line spectrum? What do you mean by the band spectrum? See, spectrum అంటే ఏమనుకున్నాము, visible of colors, అంటే combination of the different frequency of the light is known as a spectrum అన్న. Spectrum లో ఏమనుకున్నాము, two spectrums. One will be the visible spectrum, another one will be the invisible spectrum. Visible spectrum అంటే ఏంటి, the combination of the color that can be seen. Let's example Vibgyon. Invisible spectrum ఏమని చెప్తున్నాము, they are unable to see even though the colors, light is going to be arranged like a group with the different frequencies, but cannot be seen with the naked eye. Say it as a invisible spectrum, like alpha rays, gamma rays, beta rays, and etc. On the other hand, if all the different frequency light rays are going to be arranged linearly or line by line, so it is a line spectrum. If they are going to be arranged like a group, it is known by band spectrum. Light spectrum means the light rays, the different frequency light are arranged in a line by line or side by side, that can be known as the line spectrum. If all the different colors are grouped together, that is going to be known as a band spectrum. So Bohr has been explained about only the line spectrum of hydrogen, but not the higher energy atoms. He only explained about the lower energy atoms like hydrogen. Its light spectrum has been explained. And also he did not explain about the splitting of line spectrum. And he is not given a more explanation about the splitting of line spectrum. And line spectrum gunchi anta information emi ledu. Just he has been explained about the line spectrum of the hydrogen. Ante. Both, and also Bohr said that an atom is in the shape of, in the form of a spherical shape. In the form of a spherical shape. తర్వాత ఏంటి, సోమర్ఫెల్డ్ వస్తాడు. సోమర్ఫెల్డ్ ఏమని చెప్తాడు, కంపారిటివ్లీ he just supported the Bohr, but he has given that atom will be in the form of a elliptical shape. ఈయనేమో స్పెరికల్ షేప్ అంటాడు, ఆయనేమో ఎలిప్టికల్ షేప్ అంటాడు. బట్ గ్రాడ్యువల్లీ బై లూజింగ్ ది ఎనర్జీ, బై గెయినింగ్ ది ఎనర్జీ, ఎలిప్టికల్ షేప్ బికమ్స్ యాజ్ అన్ స్పెరికల్ షేప్ అని చెప్తారు. ఎలిప్టికల్ షేప్ అంటే ఏంటి, దిస్ ఇస్ యువర్ గోయింగ్ టు బి ఎలిప్టికల్ షేప్. And where is the elliptical shape, there will be a major axis, there will be a minor axis. When the length of major axis and minor axis are equal, then it becomes as a sphere. ఇది ఎవరు చెప్పింది, సోమర్ఫీల్డ్ చెప్పింది. All the concepts which are given by the Bohr has been supported with the Sommerfeld. And additionally, what is information is given, atom will be in the form of elliptical shape. By changing the energy, elliptical shape can be converted as a spherical shape. In a prakaram enti, there will be a major axis, there will be a minor axis. So that continuously by changing the energy, major axis becomes as a minor axis, the total becomes as a spherical shape. ఇది సోమర్ఫీల్డ్ చెప్పింది. ఇప్పుడు ఏంటి మనకి, as we know that the entire matter to know about the electrons. So to characterize the electrons, to know about the characteristic of the electron, there are three quantum numbers are there: spin quantum number, azimuthal quantum number, and magnetic quantum number. There is a fourth one, is the spin quantum number, but it don't characterize it. It tells about only the revolving around the nucleus. So we have only major three quantum numbers. One will be the principal quantum number, one will be the azimuthal quantum number, say it as the angular quantum number. Third one emo magnetic quantum numbers. Quantum numbers are the one which are going to characterize and which are more give about the electron is known as the quantum number. Say it as the NLM. So let's talk about the first quantum number, that is principal quantum number. Say it as a N. Principal quantum number tells about the main shells. Principal quantum number tells about the main shells and their energy. And principal quantum number represented by N. So based on that, if n is equals to 1, that is K shell. If n is equal to 2, that is L shell. If n is equal to 3, that is M shell. If n is equal to 4, that is N shell, and so on. And third point, the number of electrons to be accommodated in a orbital should be given by the formula 2n square. Based on this formula, in K shell, you will be having 2 of 1 square, that is equals to 2. In L shell, n is equal to 2, so K is equal to, L is equal to 2 of 2 square, that is equals to 8. Then in case of M is equal to 2 of 3 square, that is going to be 18. And N is equals to 2 of 4 square, that is equal to what, Nana? 32. So capacity of L is going to be 2, L is K over 2. So create the number of electrons accommodated K shell emo 2, L emo 8, M emo 18, N emo 32 based on the formula of 2n square. And the number of electrons are accommodated in a shell can be designated by the 2n square. This Bohr's atomic principal quantum number. So remember that it is trying to tell about the main shells totally, and also number of electrons are accommodated in it. Based on this, there is a other quantum number, angular quantum number or azimuthal quantum number. Say it is represented by L. Angular quantum number represented by L. It tells about the suborbital, say it as the subshells. And L it is represented by L. Third point, angular quantum number or azimuthal quantum number depends on the N. Maximum value of L is equals to N minus 1. See, for example, N is equal to 1. N is equal to how much, Nana? 0. N is equals to 2. L is equal to what? 1. N is equals to 3. L is equal to what? 2. L is equals to 4. N is equals to 4. Then L is equal to what? Just 1 less. ఎందుకంటే maximum value of L is N minus 1. N starts with 1, but N starts with 0. It tells about the subshells like S, P, D, F. S, P, D, F. And in that, it's only giving about the subshells and all. And based on this, there will be one more quantum number, that is magnetic quantum number represented by the M, and it tells about the shells in a subshells. It tells about the shells in a subshells and also orientation of the electrons into the orbital. Orientation and movement of electrons into the orbitals. See, that is called as a magnetic quantum number. That is represented by M. So it tells about the shells in the subshells. Shells in subshells, it represented by M, and also it is tells about the orientation of electrons. Orientation of electrons. And maximum value of M is 2L plus 1. Maximum value of M is 2L plus 1. And L depending on N. M is depending on L. See, as we know, N is equal to 1, N is equal to 2, N is equal to 3, N is equals to 4. N is equal to 0, L value 0, L value 1, L value 2, L value 3. Next, what about the M? M is equal to 2L plus 1, formula should apply. 2 into 0, 0, 0 plus 1, 1. ఇక్కడ ఏమవుతుందన్న m is equals to 2 1s are 2 plus 1 3. ఇక్కడ ఏమవుతుందన్న m is equals to 2 to the 4 అంతే కదా 2 to the 4 plus 1 5. ఇక్కడ ఏమవుతుంది m is equals to 7. Okay, these are the quantum numbers how to write. n is equal to 1 అయితే m is equal to 0. ఇక్కడ చూడండి, ఇక్కడికి వచ్చేసరికి ఇది s ఆర్బిటాల్ సంబంధించింది. ఇక్కడికి వచ్చేసరికి px py pz ఆ 3 వాల్యూ p లో ఎన్ని ఆర్బిటాల్స్ ఉంటాయి? 3 ఉంటాయి. ఏంటవి? px py pz. d లో ఏముంటాయి? ఇది d కి సంబంధించింది. dxy dyz, dzx, dx square minus y square, dz square, and it is not initiated so far. But there will be a 7 subshells in a f orbital. This is what it is. And there is a last quantum number which is known as the spin quantum number, which tells about the revolving of around in the nucleus. But a part of all this, one thing should be remembered: each orbital should be occupied only with 2 electrons. According to the spin quantum number, only each, it may be a px, it may be a py, it may be a pz, it may be whatever it may be. Each orbital should occupy with only 2 electrons. Among them, one should be revolving in a clockwise direction, one should be revolving in a anti-clockwise direction. So it is the energy of the total orbital divided equally into the 2 electrons. Among that, one will be the plus half and one will be the minus half. Plus half is the energy which is occupied to the electron which is revolving into the clockwise direction. The minus half is the energy which is occupied by the electron which is revolving in anti-clockwise direction. This is what about the spin quantum number represented by S. మనకి ఎప్పుడైనా ఈ 3 క్వాంటమ్ నంబర్స్ అడుగుతాడు, స్పిన్ క్వాంటమ్ నంబర్ గురించి మాట్లాడు. తర్వాత దేర్ ఆర్ ద 3 రూల్స్ టు బి రిమెంబర్. దానికంటే ముందు ఎన్ఎల్ఎక్స్ మెథడ్ అని ఉంటుంది. ఇంతసేపు మనం ఏమనుకున్నాము, నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఆర్ అకామిడేటెడ్ ఇన్ షెల్స్ అని అనుకున్నాం. ఇప్పుడు హౌ ద ఎలక్ట్రాన్స్ ఆర్ గోయింగ్ టు బి అకామిడేటెడ్ ఇన్ టు ద ఆర్బిటాల్స్, ఇది మ్యాటర్. సో దానికి ఎన్ఎల్ఎక్స్ మెథడ్ కూడా యూజ్ అవుతుంది. ఎన్ఎల్ఎక్స్ మెథడ్. ఎన్ ఇస్ నోన్ యాజ్ ద ప్రిన్సిపల్ క్వాంటమ్ నంబర్ లైక్ మెయిన్ షెల్. L is going to be known as the subshell, that is angular quantum number, tells about the subshell. X and ఏంటంటే మనకి number of electrons are accommodated. So ఇక్కడ మనకి electronic configuration is there. Electronic configuration అంటే ఏంటి, ఇక్కడ మనకి the systematic arrangement of electrons into the orbitals is known as the electronic configuration. Systematic arrangement of electrons into the orbitals can be known as what? Electronic configuration, which is given by the Moelis. So according to the Moelis, there will be the 1s orbital, p orbital, d orbital, s orbital. But remember, to represent the 30 elements, 1s, 2s, 2p, 3s, 3p, 4s, 3d. So it is enough to write the 30 electrons are available. But remember, S capacity 2, P capacity 6, D capacity 10, F capacity 14. I repeat, S capacity 2A ఎందుకని అందులో ఒకటే ఆర్బిటాల్ ఉంటుంది. P capacity ఎంత 6 ఎందుకని Px, Py, Pz 3 ఆర్బిటాల్స్ ఉంటాయి. D capacity 10 ఎందుకని 5 ఆర్బిటాల్స్ ఉంటాయి. F capacity 14 ఎందుకని అందులో 7 సబ్షెల్స్ ఉంటాయి. ఈచ్ ఆర్బిటల్ ఎన్ని ఎలక్ట్రాన్స్ ఉండాలి, 2 ఎలక్ట్రాన్స్ ఉండాలి. సో లెట్స్ రైట్ ఫర్ ఎగ్జాంపుల్ టు రైట్ ది ఎలక్ట్రాన్. ఇక్కడ చూడండి, ఐఎమ్ రైటింగ్ ద మెగ్నీషియం నంబర్ ఎంతనన్నా 12. ఫ్లాష్ రిజర్వ్ 1s2. ఇది ఫిల్ అయ్యాక మళ్ళీ 2 కి ఇవ్వాలి. ఎంత వస్తుందిరా, 2s2, 2p6. There are 10. One దగ్గర ఉన్నవి 2 electrons, but we have got that 10 electrons. So 2p తర్వాత ఏమన్నా రావాలి, 3s అంటే 3s2. ఇక్కడ చూడండి, ఇందులో m అంటే ఎవరు 1, l అంటే ఎవరు s, ఇక్కడ ఇది x. x represents number of electrons are accommodated in it. ఇక్కడ చూడండి 3s కి వచ్చినప్పుడు ఇక్కడ ఏమవుతుంది n shell, ఇక్కడ ఏమవుతుంది l, ఇదేమవుతుంది x. పోనీ పీకి రండి, ఇక్కడికి వచ్చేసరికి ఏమవుతుంది, ఇది n, ఇందులో ఇది l అవుతుంది, ఇదేమవుతుంది x అవుతుంది. NLX method. So NLX method is used to help how to write an electronic configuration. But how to arrange thereafter, the order has been given by the Moelis diagram. So this is the order to be remembered to write the 30 elements electron configuration up to zinc. చూడండి 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 10. 3d 10 అంటే ఇక్కడ 2, ఇక్కడ 2, ఇక్కడ 6, ఇక్కడ 2, ఇక్కడ 6, ఇక్కడ 2, ఇక్కడ 10. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 6 18, 18 plus 2 20, 20 plus 10 30. Total 30 electrons can be written. అంటే 30 elements రాసేయచ్చు ఈ ఆర్డర్ గుర్తు పెట్టుకుంటే. 1s, 2s, 2p, 3s, 3p, 4s, 3d. Right? And then after S orbital shape is going to be spherical. P orbital shape is going to be dumbbell. D orbital shape is going to be double dumbbell. And F orbital shape is not yet initialized. Spherical shape is this, dumbbell shape is this, double dumbbell shape is this. And again, it's a three-dimensional objects like x-axis, y-axis, and z-axis. And there are the three rules are available: Pauli's exclusion law, Harbour principle, and as well as the Hund's law. First one, Pauli's law. Second one, Harbour. Third one is going to be Hund's law. According to the Pauli's exclusion law, no two electrons will have the four quantum numbers same. No two electrons will have the four quantum numbers same. But whereas in Harbour principle, all the lower energy orbitals are filled first, then higher energy orbitals are filled. Third one ఏం చెప్తుంది? Hund's law, all the degenerated orbitals must be filled with one electron, then they will start pairing. అంటే Pauli's లో ఏమని చెప్తారు? 2 ఎలక్ట్రాన్స్ తీసుకున్నాం అనుకో, ఎవ్రీ ఎలక్ట్రాన్ కి 4 క్వాంటమ్ నెంబర్స్ ఉంటాయి. అందులో ఏ 2 ఎలక్ట్రాన్స్ కి 4 క్వాంటమ్ నెంబర్స్ సేమ్ ఉండవు అని దాని మీనింగ్ ఇక్కడ. దట్ ఈస్ రీజన్ నో 2 ఎలక్ట్రాన్స్ విల్ హ్యావ్ ద 4 క్వాంటమ్ నెంబర్స్ సేమ్. ఇందాక చూసినప్పుడు ఎక్కడ సేమ్ వచ్చినాయా? ఇప్పుడు n is equal 0 చూసాం, n is equal 1 చూసాం, n is equal 2 చూసాం, n is equal 3 చూసాం. ఎక్కడ కూడా ఆల్ ద 3 వాల్యూస్ ఆర్ సేమ్. ఇక్కడ నుండి ఆబో ప్రిన్సిపల్ కి వచ్చేప్పటికి ఏం చెప్తున్నాము? All the lower energy orbitals are filled first, then higher energy orbitals are filled. అంటే ఏంటి సార్? ఇప్పుడు k ఉంది, l ఉంది, m ఉంది, n ఉంది. ఫస్ట్ ఏ షెల్ ఫిల్ అవ్వాలి? k షెల్. ఆ తర్వాత ఎక్కడికి రావాలని? l షెల్. l షెల్ ఫిల్ అయ్యాకనే m షెల్. m షెల్ ఫిల్ అయ్యాకనే n షెల్. అంటే ఆల్ ద లోవర్ ఎనర్జీ ఆర్బిటాల్స్ ఆర్ ఫిల్డ్ ఫస్ట్, దెన్ హైయర్ ఎనర్జీ ఆర్బిటాల్స్ ఆర్ ఫిల్డ్. కానీ ఈయనేమంటాడు? డీజెనరేటెడ్ ఆర్బిటాల్స్. అసలు డీజెనరేటెడ్ ఆర్బిటాల్స్ అంటే ఏంటి? The orbitals which are having the equal energy can be known as the degenerated orbitals. Orbitals which are having the equal energy, those orbitals are known as the degenerated orbitals. అంటే ఏంటి సార్? px, py, pz ఇవన్నీ ఎవరికి సంబంధించినవి? p కి సంబంధించి. అంటే ఈ మూడిట్లో ఎనర్జీ ఎలా ఉంటుంది? ఈక్వల్. వీటిని ఏమనాలి? డీజెనరేటెడ్. KLM స్టేషనరీ ఆర్బిటాల్స్ అంటాం, వీటినేమో స్టేషనరీ అంటాము, వీటినేమో డీజెనరేటెడ్ ఆర్బిటాల్స్ అంటాం. ఇవి స్టేషనరీకి దీనికి తేడా ఏంటి? ఇక్కడేమో ఎలక్ట్రాన్స్ ఆర్ రివాల్వింగ్ అరౌండ్ ద న్యూక్లియస్ ఇన్ KLMN, ఎనర్జీ నెవర్ బి చేంజ్డ్, దట్స్ వై దే ఆర్ స్టేషనరీ ఆర్బిటాల్స్. ఇక్కడైతే ఏమంటున్నాము? ఆర్బిటాల్స్ which are having the equal energy, those orbitals are known as what అన్న? Degenerated orbitals అని చెప్తాం. ఇప్పుడు Hund's law ఏమంటారు? All the degenerated orbitals must be filled with one electron, then they will start pairing. అంటే ఎట్లా సార్? ఇక్కడ చూడండి, ఫర్ ఎగ్జాంపుల్ నేను 2p4 అని ఇచ్చినాను. ఓకే, 2p4 అంటే నేను ఎలా ఫిల్ చేయాలి? డీజెనరేటర్స్ ఎన్ని ఉంటాయి? 3 ఉంటాయి. ఫస్ట్ 2 ఇచ్చుకుంటే వెళ్ళకూడదు అంటాడు. ఇట్లా ఇవ్వకూడదు. దిస్ ఇస్ ద రాంగ్ మెథడ్. ఫస్ట్ యూ షుడ్ గివ్ ద 1 ఎలక్ట్రాన్. అంటే ఇగో ఇది 1 2 3. ఇఫ్ దెర్ ఈస్ ఎనీ ఎక్స్ట్రా ఎలిమెంట్, అగైన్ యూ గో ఫర్ పేరింగ్. ఇది రైట్ మెథడ్. అప్పుడు px లో ఎన్ని ఉన్నాయి? 2. py లో ఎన్ని ఉన్నాయి? 1. pz లో ఎన్ని ఉన్నాయి? 1. అప్పుడు లోడ్ ఎలక్ట్రాన్స్ అంటే ఎవరు? py, pz. పేర్ ఎలక్ట్రాన్స్ అంటే ఎవరు? 2px. ఇది Hund's law. Okay, this is what exactly is trying to give you. అడుగుతారు, what is a Hund's law, what is a Harbour principle? ఎలక్ట్రానిక్ కాన్ఫిగరేషన్స్ రాయమంటాడు. తర్వాత ఎక్స్ప్లెయిన్ అబౌట్ ద NLX మెథడ్ అంటాడు. రైట్ అబౌట్ ద క్వాంటమ్ నంబర్స్ అంటాడు. వాట్ ఈస్ ద స్పెక్ట్రమ్ అంటాడు. ఇందులో అడగలిగే క్వశ్చన్లు. తర్వాత ఎలక్ట్రానిక్ కాన్ఫిగరేషన్స్ రాయమంటాడు. లేదా ఎక్స్ప్లెయిన్ అబౌట్ ద బోర్స్ మోడల్ అంటాడు. లేదా వాట్ ఆర్ ద లిమిటేషన్స్ ఆఫ్ బోర్ అంటాడు. ఇందులో అడగగలిగే క్వశ్చన్లు ఇవి, ఇంకేం లేవు. 1-2 సార్లు చదివి ఆ టాపిక్ రాస్తే మనకి ఏమన్నా అర్థమవుతుంది. Keeps on reading is not the matter. Whatever you read, try to present on the paper. That will be useful.